Hi, this is Mrs. Robertson. Today, during my sixth period math cluster class, we're going to go over our bell work. This worksheet is going to be very similar to what your test looks like on Thursday. So let's go over the answers to this bell work. Probability practice. Number one, the probability of spinning a 5 in the spinner here is there's only 1 5, 8 possibilities, 1/8. What is the likelihood of spinning a 3? Well, there's only 1/8, so it's unlikely. The probability of spinning a 15? 0. It's impossible because there is no 15 on the spinner. The probability of spinning white, that's 4/8, which is 1/2, and that is the same thing as 50%. Number 5, what is the likelihood of the probability being greater than 2? It's going to be likely because with that, you have 1, 2, 3, 4, 5, 6 eighths, which simplifies to 3/4, which it's greater than 50%, so it's going to be likely. In question number 6, if you roll a number cube 36 times, about how many times could you expect to roll a number greater than 2? Well, there are 4 numbers out of 6 that are greater than 2. And you're going to take that times the number of times you're going to roll the cube. So you're going to have 4 6 times 36 over 1. I would simplify before you multiply. 6 will go into 6 once, 6 goes into 36 6 times, and the answer will be 24. Any questions? That would be considered theoretical probability. Joe finds the experimental probability that he'll make a field goal is 36%. Out of 400 field goal attempts, about how many could he predict to make? You're going to take 36%, change it to a decimal, and multiply it times how many attempts? 400. So if you have 400 times 0.36. Now, on your test, kids, I want to point this out to you. This is a 2-point question. 1 point for work and 1 point for the answer. So if you did not read carefully and only give me the answer, you would only get half of your points, even if your answer is correct. So read carefully. The same thing for this one. You have to show 400 times 36 hundredths equals 144. 1 point, 1 point. Are there any questions? Okay, let's go on to the next page. In number 8, it says if a die is rolled and the spinner below is spun at the same time, about how many outcomes are possible? Show your work. To figure this out, you use the fundamental counting principle. The fundamental counting principle says you take the number of outcomes for the first event times the number of outcomes for the second event. So for the first event, there are 6 possible outcomes. 1, 2, 3, 4, 5, or 6. On the spinner, there are 4 different outcomes. So you are going to take 6 times 4. You have to show the 6 times 4 for 1 point and the answer 24. You could also put 6 times 4 equals 24, but you have to show how you get the 24. Any questions? It could be that you wanted to show your work by doing a tree diagram. And yes, here is a tree diagram for this. You have your number cube. You could be a 1, a 2, a 3, a 4, a 5, or 6. And then you're spinning 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4, 5, 1, 5, 2, 5, 3, 5, 4, 6, 1, 6, 2, 6, 3, 6, 4. Then there's your tree diagram. If it asks for a sample space, what is a sample space? This is where you list the outcomes. 1, 1, 1, 2, 1, 3, 1, 4, da, 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 da. And you write down, you end up having 24 sample spaces. Are there any questions on how to do a tree diagram or a sample space? Do you see the difference? You won't have open notes on your test. For those of you that are doing the quiz, you are allowed to use your notes or your books on the quiz. Okay, any questions on how we got the 24? Very good. I like the fundamental counting principle the best. It's the easiest, 6 times 4. Number 9, the spinner is divided into 8 equal-sized sections. Each section is labeled with a color. Now this is 3 points. The 3 should be right here in front of the points. So we have 3 points. So on this one we have arrow lands on a section labeled with blue. Well, there are 1, 2, 3, 4. So 4 eighths, which equals a half. Arrow lands on a section labeled with white. There's only one of those. Arrow lands on a section labeled with red. Well, with red, you have 1, 2, 3. Okay, so the least likely is going to be B. The most likely is going to be A. And the one in the middle is C. So you put them in order from least to greatest for your A, B's, and C's, okay? Yes?
Instead of putting A, B, and C, I just put what color.
Okay, that would be fine. I will tell you, if this were a Mastery Connect, you would want to do B, C, and A because they'd probably count it wrong. All right, I would go back in and I would fix it. But this way you now are more familiar with what they're expecting. Any questions on question 9? Okay, let's go to number 10. This problem is worth 6 points. So make sure you do it right. List all the outcomes in the sample space. Well, you're going to have H1, H2, H3, H4, H5, H6. Then you're going to do the tails. Tails 1, T2, T3, T4, T5, T6. Does everyone see how to do this? All right, that's 6 points right there. What's the probability of getting T6? There's only one out of 12. A 3 or a 4, there are 2 of them. I think on the Mastery Connect test, they're requiring you to simplify your fractions. So just make sure you do that and be careful. Letter D. Show the work for the fundamental counting principle to prove the number of outcomes. This is worth 2 points. Why? You show your work and you give the answer. So whenever you see 2 points, make sure you show your work. So the work will be 2 times 6, and that equals 12. 1 point, 1 point. Any questions on this? All right, now let's go to the last one. Your option for ice cream at a local ice cream shop includes the following. Make a tree diagram of the ice cream options. Okay, you can do sideways or vertical. I'm going to do it vertical. So I start off with my 3 flavors of ice cream. I'm going to use V for vanilla, C for chocolate, and S for strawberry. Now I go to my second branch, caramel or hot fudge. I'm going to use C for caramel, H for hot fudge, C for caramel, H for hot fudge, C for caramel, H for hot fudge. Now I'm going to go to my next branch. We have 3 branches here. And the last one is going to be sprinkles, M&Ms, and gummy bears. I'm going to use an S for sprinkles, just one M for M&Ms, and a G for gummy bears. So here we go. C sprinkles, C M&Ms, C gummy bears. H sprinkles, H M&Ms, H gummy bears. Sprinkles, M&Ms, gummy bears. Sprinkles, M&Ms, gummy bears. Sprinkles, M&Ms, gummy bears. Sprinkles, M&M, gummy bears. All right, so we've made a tree diagram. Any questions on the tree diagram? So if I had to list my sample space, let's do a sample space with this one. It would be vanilla chocolate sprinkles, vanilla chocolate M&Ms, vanilla chocolate gummy bears. Then I would have vanilla hot fudge sprinkles, vanilla hot fudge M&Ms, vanilla hot fudge gummy bears. Write these down. I know you don't have them because I just created this problem. Now we're going to go to chocolate. Did I get all of them? Yeah, 6. So now we have chocolate caramel sprinkles, chocolate caramel M&Ms, chocolate caramel gummy bears. Chocolate hot fudge sprinkles, chocolate hot fudge M&Ms. This is making me hungry. Chocolate hot fudge gummy bears. Now we're going to go to strawberry. Strawberry caramel sprinkles, strawberry caramel M&Ms, strawberry caramel gummy bears. Our last group of 3, strawberry hot fudge sprinkles, strawberry hot fudge M&Ms, strawberry hot fudge gummy bears. Any questions on the sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I use the fundamental counting principle, it would be 3 times 2 times 3, and that will give you 18. Any questions on that? I did all of those things just in case on the test you do a problem, they want the fundamental counting principle, they want you to do a sample space, and there we have a tree diagram. Yes?
So if there's a tree diagram and it's like that, we have to do it all?
If there's a tree diagram, you will do it all because it's going to be worth more than 2 points. That's a 6-point problem. Okay? Now, let's go on to the next one. A number cube was rolled 30 times, and the results are as follows. They landed on a 1 4 times, a 2 5 times, a 3 7, a 4 6, a 5 3, and a 6 5. Okay. What is the experimental probability of rolling on a 6? This is the experiment. And according to the experiment, this is not theoretical, according to the experiment, landing on a 6, you landed on a 6 5 times. Okay. So 5 times out of 30 equals 1/6 of the time. Any questions on that? All right. Now, what is the theoretical probability of rolling a 6? Well, how many 6s are on a dice? 1 out of 6. It's actually the same. Compare the experimental probability to the theoretical probability. On this one, they are the same. Now let's do another one where they're different, okay? So this time, let's say rolling a 1. What's the probability of rolling a 1? The experimental probability of a 1. Well, it only happened 4 times out of 30. 4 over 30. And that simplifies to 2/15. Okay? The theoretical probability of landing on a 1 is what? What's the theoretical probability of landing on a 1? Yes. Huh? 1/6. And 1/6, if we want to have common denominators, is the same thing as 5 over 30. Okay, see how I found common denominators? So, the experimental probability for landing on a 1 is 1, if we change it, 5/30 is 1/30 less than the theoretical probability. Because the chances are, if they ask this question on the test, they're probably not going to be the same, right? So this is what you would do for something where they're not the same. Landing on a 1 is 1/30 less than the theoretical probability. Any questions on that? And then our last question. Give an example of an outcome that would result in a probability of 1 from rolling a number cube. That means it's certain to happen. The probability of 1 means it's 100%. 1 is the same thing as 100%, which means it is certain it is going to happen. So I am going to say you roll a number cube. You roll a 6-sided number cube. And you will land, you roll a 6-sided number cube and land on a 1, a 2, 3, 4, 5, or 6. On a 1, 2, 3, 4, 5, or a 6. Yeah, it's a 6-sided number cube that's got 1, 2, 3, 4, 5, 6 on it. So what is your chance of landing on a 1, 2, 3, 4, 5, or 6? 100%. A 1 means 100% and it is certain. Any questions? Okay.